Hello, hope you're going well. So this video, this topic is a little bit niche, but it's a fun little afternoon of hacking. Let's say, for instance, that we want to use assembly within Rust. And, that is a bit of a niche topic, but here's a valid use case for that. Let's say we want to get the sign of a number. So this is a function which will indicate -1 if the number's negative, 0 if it's 0, and 1 if it's positive. And let's say we want to implement that ourselves. Now it turns out I've been reading the book Hacker's Delight, which I strongly recommend, and it gives us a useful formula. Let's say that we have a 64-bit number. We basically shift everything down right, but we do what's called a sign shift, and then we do a bitwise OR with the negative of the number, unsigned shift by 63. Now, what do I mean when I say signed and unsigned? Well, with an unsigned shift, we basically take the number, treat it as a whole bunch of zeros, move everything, and then the zeros which we have to pad in to the most significant bits, they don't really matter. They're not taking any significance, so we just fill them with zeros. Whereas in a signed shift, if we have a negative number, the most significant bit will be 1, and that is important. We don't want to shift a number and then have it change sign. So the leading, you know what I'm saying, the most significant bits are maintaining the original sign of the number. Now this is something that you can't, well, as far as I know, you can't directly do it in Rust, because in Rust, the compiler will look at your number, and if your number is a signed number, it will perform a signed shift. And if it's an unsigned number, it will perform an unsigned shift. And that's pretty cringe to me, because it's literally an assembly instruction. So this is not the most interesting case, but it is a valid use case where we can express something in assembly that we can't express in vanilla Rust code. Just a side note, this is going to be set up, the assembly part of it is going to be set up for Mac, M1, Apple Silicon, but hopefully there will be enough concepts here that if you're familiar with assembly language, you can swap out whatever assembly stuff you want to write, and the build process will be the same. So I've just got a fresh project here, and the first thing I'm going to do is I'm going to set up my build environment so that I can include an assembly file, build that, and then link it into the program. So I'll go over to my Cargill TOML file. I'm going to specify a few things. I'm going to specify the build script that I want to run. And then I'm also going to specify the dependencies for that build script. So there's a Rust crate called CC, which is used for compiling C code, C++, assembly, all of that. So I'll just say, okay, got this set up. Then I'm going to go and I'll make a new file, which I'll call build.rs, and this will be my build script. Now in my build script, the thing which gets executed is the main function. And the idea is I want to go into CC, here we go, build new, and then I'm going to add a file, and this file will be inside source files. I'll call it asmstuff.s. Haven't built this yet, haven't made it yet, but that's what it will be called. So this will add a file. If we had multiple source files, we could just keep adding file. Okay, and then what I'm going to do is I'm going to instruct this to compile. And now we'll need to put basically a name for the library, and this is just like a temporary binary library, so we don't need to worry about directories or anything like that. It gets directly included in the executable. So I'm just going to call it my as ASM library. Okay, cool. So this will go ahead and build it, but there's a funky feature with the build script, and that is that when I go ahead and I build my assembly file, it will sort of build it and link it the first time. But then if I modify my assembly file or I modify my Rust file, the build will not be redone, which is sort of annoying, a little bit cringe. What we would have to do is pop in here and modify this file directly. It's not, I would not recommend it. So here's a hack that I found online to force this to rebuild every time. So what we could do is we could put in here a file name and get the build script to rerun anytime the file name is changed. Turns out, pro tip, if you put in null, it will just force it to rebuild every time. So I don't know if this is going to break anything, but it's been working for me so far. So what I'll do is I'll make a new file and I'll call this my asmstuff.s. That's my assembly file, and I'll just put in some stub code here. Very simple. It does nothing. I just want to get the definition there. So then I'll go over to my main file, and what I'll do is I will just declare this function. And why not? Let me do this. So I'll say, all right, we take a 64-bit integer input and we return a 64-bit integer, just like that. You can set this up any way you want. Now this is going to be unsafe. So there's a few things we need. We need to declare the function, the external function, and then when we call that function, that needs to be an unsafe call because it's not Rust code, it's compiled code. Put it in like this. Okay, so I'm exploiting a few things. The return function will automatically send back whatever is loaded into register 0, and by default, register 0 is always loaded with the input. That's the calling convention in ARM64 assembly. So this is really just the hello world of assembly. Let's give this a go, see what happens, and we can see that down below it's printed out that -3 that we put in there. Very cool. Okay, so let's start actually doing this. We'll go sign of -3, and then we'll go ahead and do that. So this is the point at which things are going to start really getting platform dependent. If we had a bunch of different platforms, we were writing code for a bunch of different platforms, it's totally fine to actually declare this same code in a number of different assembly languages, and then in the build script to do some sort of conditional test to check which of those to execute. But yeah, so if I look at this, I see we have this OR statement. The left side of this, I'm going to make this register x0. The right side is going to be register x1. So the first thing I'll do is I'll take a copy of x0 and I will move it into x1. And then I will make the contents of x1 negative under 2's complement. And then what I'll do is I'll do an unsigned shift. Now an unsigned shift is also called a logical shift. So I'll go logical shift right. I'll store the result in x1. The shift will be shifting x1 by an immediate value of 63. Whoops, haha. And then I'm going to work on x0. So a signed shift is called an arithmetic shift. So I'll apply an arithmetic shift, store the result in x0. I'll take x0 and shift it by the immediate value of 63 bits. Then finally, I'll take the OR of these two. Final result will be stored in x0, sorry. and it will be x0 or x1. There we go. And yeah, return is going to whatever was last written into x0 will come back. There are some other bits of bookkeeping we could do, but this is such a simple function that this will get the job done. So we can go over to our function, run it, and it's giving us the correct, sine -1. We can go ahead and play around with this a little bit. Sine of 0 and sine of 7. Cool, let's give that a shot. Cool, and that seems to be working correctly. So if some of this assembly stuff was a little bit don't worry about it. The point of this video was not to necessarily get into the weeds of how to write assembly code. The goal of this video was to show how to set up a project which can call assembly code, and not just inline assembly, but actually compile, link, and call that code in a hopefully robust way. Okay, so I hope you enjoyed that. This is a fun little afternoon of hacking, and I will see you again soon. Bye.